The two-stroke cycle engine has re-emerged, being used in ultra-light, light sport, and many experimental aircraft. As the name implies, two-stroke cycle engines require only one upstroke and one downstroke of the piston to complete the required series of events in the cylinder. Thus, the engine completes the operating cycle in one revolution of the crankshaft. The intake and exhaust functions are accomplished during the same stroke. These engines can be either air or water-cooled and generally require a gear reduction housing between the engine and propeller. In comparison to a conventional four-stroke power plant, two-stroke engines have some unique operational features. Oil is mixed with the fuel to lubricate the connecting rods and bearings associated with the crankshaft, wrist pin and bearing, and rings and cylinder wall. This oil is consumed during the ignition and power stroke of the engine. Also, two-stroke engines often run at relatively high RPMs. The cylinders of two-stroke engines contain a series of ports that are crucial to the operation of the engine. These ports are blocked and unblocked by the piston as it travels up and down the cylinder. The locations and dimensions of these ports are engineered to provide the desired performance of the two-stroke engine. The piston rings of a two-stroke engine are different from those of a four-stroke power plant. The rings are pinned within the ring groove to prevent their rotation during operation. If the piston rings were free to revolve in their grooves, the ends of the rings would become snagged in the cylinder ports, resulting in ring and ultimately engine failure. Also, two-stroke engines do not use oil and scraper rings as the lubricant is mixed with the fuel-air charge and consumed during the combustion process. The intake flow of the fuel/air/oil mixture begins as the piston travels to top dead center. Unlike a four-stroke engine, the crankcase has sealed chambers for each cylinder. The movement of the piston from bottom dead center to top dead center generates a low pressure in the crankcase chamber. This action draws the fuel/air/oil charge into the crankcase chamber. As the piston travels from top dead center to bottom dead center, the fuel/air/oil charge contained in the crankcase becomes compressed. When the piston unblocks the transfer ports located along the cylinder wall, the fuel/air/oil charge travels from the crankcase chamber into the cylinder. After reaching bottom dead center and moving toward top dead center, the ports along the cylinder wall are blocked by the piston. This allows the upward moving piston to compress the fuel/air/oil charge before the ignition event. As with the four-stroke engine, the combustible mixture is ignited before the piston reaches top dead center. After ignition, the pressure generated by the expanding gases increases as the piston reaches top dead center and travels down the cylinder wall until the exhaust port is unblocked. Exhaust gases escape through the exhaust port. As the piston continues its downward movement, the transfer ports are open to allow the fuel/air/oil charge in the crankcase chamber to flow into the cylinder for the next cycle. One advantage offered by the two-stroke engine is its relative lightweight when compared to the four-stroke engine. The time between overhaul is generally shorter on a two-stroke engine than a four-stroke engine. Overall, the overhaul of the two-stroke is somewhat simpler due to the lack of intake and exhaust valves and a number of other components included in the four-cycle engine.